Hello everyone, and thank you for attending today's webinar, How High-Performance Antennas Drive Network Excellence in North America, sponsored by Ericsson. Before we begin, I'll cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, please type them into the Q&A box, and your questions will be passed on to our speakers, who may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download using the blue Resource widget. At the end of today's presentation, please take 1 minute to complete the survey that's open on your screen. Your feedback is extremely helpful. I would now like to turn the event over to Heavy Reading's Senior Principal Analyst, Gabriel Brown.
Thank you, Matthew, and hello, everybody. Welcome once again to today's webinar, How High-Performance Antennas Drive Network Excellence in North America. It's terrific to have you with us. Thank you for coming. The focus of the session today is on how passive FDD antennas can contribute to network service quality, and from there help operators build an advanced connectivity services portfolio. The background really is we have now in North America widespread deployment of 5GSA. Operators have built tremendous networks. They're still building and investing, but they've got tremendous capability now that they really want to turn that into service innovation and ultimately better business outcomes for them and their customers. So the outlook for SA in the region is strong. A lot of pieces are coming together. And we probably, it looks like we're at the start in the industry of a sort of shift in how operators and the industry in general serves customers. It's actually pretty exciting. And so bringing to the topic of today, we have the antenna system is the entry and exit point into the network. It's very clear that a well-engineered, precision manufactured antenna can increase real-world performance and, of course, user experience. And so in the webinar today, we're going to draw a line directly from antenna design to network performance. And from there, there's some other pieces we can get into. My name, as you heard, is Gabriel Brown. I'm an analyst with Omdia, actually, now we've called ourselves. We've just rebranded from Heavy Reading, but formerly known as Heavy Reading. We're now under the Omdia brand. I'm your host and moderator for today. We have two expert guest speakers with us today, both from Ericsson. So first of all, I'd like to introduce Rodrigo Gulat. He's VP and Head of Market Area Americans for Ericsson Antenna System. Welcome, Rodrigo. Great to have you with us today. Please tell us a bit about who you are, your background, and so forth.
Likewise. Thanks for. It's great that I'm here. So. I have been in Ericsson for the last 26 years, and I have played multiple roles from operations, more recently to sales, and have had the opportunity to live in different countries. And it's pretty amazing the transformation that and the speed of that transformation that we're seeing right now.
Yeah, great time. We also have Ranjit Bhattacharya. He's VP and Head of Network Products, Market Area America for Ericsson. Ranjit, great to have you. Please introduce yourself.
Great to be here. Thank you, Gabriel. Good morning, good afternoon, everybody. As Gabriel mentioned, I am Ranjit Bhattacharya. I'm heading up the Network Products team at Market Area Americas. And our mission basically is to provide world-class radio access network solutions to our customers in North and South America so that they in turn can provide best-in-class services to their end customers from whatever the customer base may be. So great to be here. Thank you.
Yeah, great to have you, Ranjit. And just a note here, obviously we've got some prepared materials we're going to go through in a moment, but both speakers, they're really open to questions. I have a bunch of pre-prepared questions. Some of the speakers don't know about, honestly, but I'm keeping them in my back pocket. If you have a question for for either of these gentlemen, please type it in the Q&A tab on your screen. I'll endeavor to get to it, put it to our speakers as long as it's appropriate, of course. If for some reason it's super technical or it's deep or it's into some tangent that they can't handle, I'll also ask the team where appropriate to get back to you afterwards as well. So don't be shy on the questions. I know they're both really open to taking it. Although we have a ton of slides and stuff like normal, the discussion and question are often as useful and revealing. So, take advantage. I'm going to go, in terms of agenda, I'm just going to give one slide of introduction and I'll let you know a little bit about the rest of the session, how it's going to run. So I have just one slide actually here. A chart is extracted from our 2025 5G Network Operator Survey. And we asked qualified operator professionals in terms of their enterprise customers, how commercially attractive are premium 5G connectivity services in your national market. We asked them to rank it on a scale of 1 to 5, with 1 very attractive, will generate a lot of additional revenue, 5 not attractive, little additional revenue from a premium connectivity play. Now, the chart compares North America to the rest of the world, obviously because we're talking, you know, if there's people here who aren't from North America, you're very welcome, by the way. You know, we'd love to have you as well. But that's just a little bit the reference we're using. And you can see in both regions, you know, the leaning is sort of towards the positive if you take the midpoint of 3 as a sort of a neutral in that sense. But, you know, clearly there's more ambition here for a differentiated or premium connectivity play in North America. We have 31% rank 1, very attractive, versus 13% in rest of world. Now, some of this enthusiasm, honestly, is natural American bullishness and just, you know, yeah, we're gonna go and get them, you know, which we love. There are, I must say, a fair few Canadian operators in this 42 here as well, so they temper a little bit, bring the temperature down, and so, you know, take all that into account. Expectations are running pretty high in the North America region. I think this really bears out as well in like news flow, operator marketing, commercial product development, and all those activities. Just this week, we've seen 2 big North American operators put out, you know, advanced enterprise 5G application statements on, you know, where they're taking their service portfolio. So I think it bears out in lots of different ways. To get to the point of today's session, when we think about antennas, we think about, for example, the importance of cell edge performance, or let's say uplink, on a premium or differentiated connectivity offer. You really start to see the importance of, you know, not leaving performance, you know, not leaving it on the table, getting it right at the best performance you can. So we're going to move on now. I'm going to ask Rodrigo to say a few words of introduction here. He's going to sort of situate for you a little bit, you know, what Ericsson's doing in the antenna business and, you know, why this sort of matters so much. By applying some new engineering and manufacturing techniques, there are a lot of gains to be made. That performance, yeah, that, you know, we don't want to leave it on the table, and we can capture that right there in the RF domain. So he's just going to situate a little bit where antenna sits in the overall kind of thinking about network performance. Just a couple of slides, a short section that we'll then go to hear from Ranjit. He's going to take us through how intent-driven and service-aware RAN is really starting to create a new type of connectivity services model, a new portfolio, if you like. It's technical, but it's rooted in what service it delivers. We're then going to go back to Rodrigo for the more detailed comment into the antenna system itself. So that's where we're going to get into the PIM, the beam efficiency, and all those kinds of things as well. So, like I said, welcome to put some questions in. But with that, I'm going to hand over to Rodrigo to just take us through and get us going, please.
Thank you, Gabriel. So to your point earlier, very well made, antennas are a super critical component of the network. And as such, Ericsson sees those antennas, the high-performing antennas, are the gateway to achieve high-performing programmable 5G networks. So what is that? I mean, high-performing networks, they require better performance, better TCO, sustainability front and center, and then when it comes to programmable, then intent drive, AI-powered, and service-aware. Now, the question is how antenna correlates to that, and we're going to dive into that later on. But at a high level, high-performance antennas allows for improved uplink and downlink, improved coverage, improved capacity, even energy savings on both sides of user and the operator, and then combine it in the near future with our apps that will allow those networks to be fully configurable real time. So antennas are therefore a very critical component of making sure that the operators are extracting the best of they can from the 5G network. So in line with that, Ericsson has established a very robust and reliable, geo-resilient global footprint. So we have, as you can see here, R&Ds in Germany and here in Plano, specifically here in Dallas, the R&D develops the antennas that we are selling here in US market. We also have strategic locations in terms of manufacturing, covering Mexico, which again feeds the US market, India, China, and Romania. And then in addition to that, we leverage all the logistics hubs that Ericsson has across the globe to ensure that we have a good lead time, and we are a very trustworthy partner to our customers. So with that said, I will now hand over to you, Ranjit, to speak a little bit of what means exactly the high-performance networks, and then we are going to go and dive into the connection with antennas.
Thank you, Rodrigo. I really liked how you talked about high-performing and programmable network. Maybe I start with a very rhetorical question. Why do we need a high-performing? It's kind of obvious, but why do we need a high-performing and programmable network? And I would say the reason is primarily because we are essentially seeing a paradigm change. And this paradigm change, what we're seeing is both from a business paradigm perspective as well as from an operations perspective. And what do I mean by the business paradigm change? Again, I think everybody is quite familiar with what's happening in North America right now is that operators are moving away from one-size-fits-all, best effort kind of a service to a more differentiated connectivity services. Again, differentiated connectivity is, of course, something that we are pretty familiar with on a day-to-day basis, right? If I want to go to the airport in 20 minutes, I take the tollway, I pay the toll, and get to the airport in 20 minutes. If I want to go to the airport through a scenic route, I have a lot of time. I don't pay the toll, and I take maybe 45 minutes or 1 hour to get to the airport. Just like that. So it depends on what the end user uses and what their requirements are. There could be different ways the network can serve the end customer. And that's what we are getting into. It's pretty basic, and it has to happen on the 5G network, and we are seeing that happening today. So what does that mean? That basically means that we are getting into a network which is not only complex from the perspective of number of bands, amount of technology we have, and on top of that, now we are adding differentiated connectivity with different customers having different use cases, and we have to do the observability, etc. So which basically means it tremendously increases the complexity of the network. So the direction that we are seeing our customers are going towards is migrating or evolving towards an autonomous network. Now, every customer is at a different level of where they are in this journey towards a full autonomous network. But essentially what autonomous network is all about is looking into providing the intent, what the network you have to provide, adapt the network, and observe how the network is behaving, and again, make adjustments and going through the cycle itself. So all in all, what we're seeing is that we are going into a new operations paradigm as well, where we are going from a very static management of the network to a much more dynamic autonomous network. And all this is possible because we are able to actually have a closed loop automation through a service-aware network. The network is aware of what service it needs to provide to the end user, and then it correlates, have a closed loop automation in there, and then make adjustments accordingly. Now, is this all a pipe dream? Is it something that something is on the slideware? And the answer is no. We are actually seeing a significant traction already in the market here in the US and in Canada. And what you see here is I picked up just a few examples of some sample use cases that we are already seeing with regards to differentiated connectivity, where you have live production where over a 5G network, or you have mission critical services being provided by the end customer, gaming services as well, enterprise productivity. What I'm not showing in this picture is, of course, AI is such a big topic right now. And all this is adding a huge amount of demands to the radio network. And Gabriel talked about it, and Rodrigo, you mentioned as well, things like uplink. We are seeing a tremendous demand on the uplink, for example, which is going away. Previously, we used to see 90% downlink, 10% uplink, typical dimensioning of a network. We are now looking into growing this. The uplink seems to be growing more than 100% year over year is what we see in the networks today. And this is going to go even exponentially higher as we go into more use cases. AI gets into more prevalent in the network by our end customers. AR, all these will add to this. So basically, it means that the network, because of all the complexities coming in and the demand and the differentiated connectivity, there is a huge amount of demand that's putting on the radio network. And I try to summarize this in very broad, high-level 3 areas that the radio network is, the demands on the radio network. First and foremost, of course, it's table stakes. Best-in-class radio network performance is what is essential for providing this differentiated connectivity. You have to provide the best services, and the radio network has to be best-in-class. And providing a fantastic radio with best-in-class power efficiencies and output power and sensitivity, etc., will have no meaning if you do not have a proper antenna to go with, right? Just like as Gabriel mentioned, antennas is the input and output of a radio network. That's where rubber hits the road. So antenna plays a significantly important role in the network today. And what we are also seeing is that FDD is also a very, very important area as well, because of the fact that this is where you are able to get the coverage, like deep indoor. FDD is where we are able to serve the customer. So FDD performance using passive antennas, high performance passive antenna is super important, of course, together with radios, and that goes together with it. Sustainability and future-proof deployment. Of course, this is a top of mind for any customer. Everybody wants to reduce their energy consumption year over year. Sustainability is, of course, top of their mind. So having a radio and an antenna, the radio network combination that essentially reduces the number of sites that is needed, using, say, for example, high-gain antennas, or provides much better connectivity without adding new sites, or is something that the operators are looking at quite extensively. And last but not the least, as we talked about earlier, as the networks is getting more and more complex, autonomous network is the direction all the operators are actually going to. They're at different levels, and like TM Forum has the 5 levels, and they're at different levels, and the journey is on for different operators. Now you might ask, okay, what does passive antennas have to do with the autonomous network? And interestingly, it does. And there are some interesting use cases that we are seeing and discussing with our customers that kind of applies passive antennas together with the autonomous network itself. But before I jump into that, one topic that often we come across nowadays is the intent-based automation. This is one of the founding steps that needs to go into when you're getting into this, say, for example, this level 4 of autonomous network. What is intent-based automation? I have a very simple analogy to explain what I mean by intent-based automation. And I like to correlate that to like driving a car using, say, for example, the adaptive cruise control mechanism. I want to go from one place to another. I have set my vehicle up to that I should not crash into the next vehicle, and I need to have at a speed of, say, for example, 60 miles an hour or 70 miles an hour, and then I start to drive. And that's the intent. I put in that intent. That's me as a driver. I put in that as an intent into my vehicle. And then the vehicle basically is the intent handler. It basically keeps track of what the network is and how the traffic is. And it determines, it keeps a distance between me and the vehicle in front of me, etc. Of course, if you're looking at the other autonomous driving vehicles that's concerned, I mean, that's even one step further ahead. But taking a step forward, that's how I correlate that to intent. It's exactly the same way. What we're looking at from an intent handling perspective is that a business owner provides a very high-level intent. Okay, I need to provide such and such user experience to the end customer. It doesn't have to, the intent provider doesn't have to go into details. What happens is the intent handler will then decompose the input that comes in from the input through the intent API and decompose that into various radio configuration parameters, and would then go into executing in the network. So that's a very high level how at what we mean by intent handling and how that's work. And then the question comes, okay, so what about the passive antennas then? How does that all fall in place together? So to do that, I kind of tried to put together a very simplified picture of an example. Again, this is highly simplified, as you can imagine. What you see here is this is a network where the customer or this service provider wants to provide a service, a kind of a guaranteed service where you have 100 Mbps of downlink and 10 Mbps of uplink at any time during the day, busy hour or lean period. So that's the intent. That's the intent that goes into the network. It could be an RAP that basically interfaces to the intent, and then the management and orchestration layer basically decomposes the intent back to what the configuration needs to be at the radio network to provide that particular service. And in this example, there's an example of where, for example, where we work here in Plano, in Texas, there is an area where there are a lot of offices around. We all move from our offices and come to this area. So obviously during a period of say 8 to 5, there's a lot of traffic in this area. So it's a cell site serving my building here in this Ericsson office, a lot of people here during this period. The intent is that I need to provide this service provider needs to provide 100 Mbps. So you could do a cell shaping using massive MIMO, or you could, if you have using your FDD antennas, you could use the remote electrical tilt to point or focus your energy into this building itself so that you get best user experience inside this building. There could still be other users further away, but in that case, those users could actually be handled through maybe a neighboring cell, which has tilts up. Similarly, when the user goes back to their houses at the end of the day at 6 p.m., between 6 to say in the evening, and then the intent could be to, okay, now it decomposes the information, and now instead of tilting down, it could probably tilt up and then cover those users that have gone back to the houses. So cell shaping on massive MIMO, cell shaping using remote electrical tilt, using closed loop automation like this are some of the areas that we are looking into so that it can automate and simplify the management of the network and also provide the best user experience the customer wants to give to their end customer. So that's basically at a high level what you're seeing from the perspective of why programmable network and how kind of it fits together. Now, with that, I will probably again hand it over back to Rodrigo to talk a little bit more about how in detail as to how antennas, these unsung heroes of the 5G network, basically serve the end customer. So Rodrigo, back to you.
Thank you, Ranjit. Doubling down the analogies, one analogy that I think it's very applicable to this conversation is that you don't buy a high-end sports car and then you put a bicycle tires, right? So similar with the antennas, you want to make sure that you have the best high-performing antennas to be able to extract the maximum out of your network. So in line with that, let's zoom a little bit more into antennas and how antennas allows for high performance and programmable networks. So let's start with just to level set, those networks, moving from a one network fits all to a multi-purpose network requires different levels of SLAs and requirements, depending on the use case. As you can see here, you can go on the uplink, fixed wireless access, there is no uplink requirement. But then when you move into AR, VR, then you can see that that increases more and more. Along those lines, as everyone knows, AI and VR, augmented reality, use cases are just growing exponentially. There's a lot of investment. And if you think about it, that intelligence is sitting more and more closer to the end user on the user device, which means that flawless connectivity is going to be fundamental to ensure that those use cases work properly. And what the implication of that, as Ranjit said, is that there is a much stronger need for uplink. That's what we are seeing. Uplink is growing much faster than downlink. So the question becomes, what can be done to improve the uplink, which is in the critical path of those applications, so to speak? Well, we have several tools that can be leveraged, and each of those tools have different CapEx requirements. But starting from the less intensive CapEx requirement, you have software features that help us to improve the uplink and the overall performance. On the other extreme, you have site densification, meaning adding new sites, small cells, indoor dedicated coverage, and that's quite CapEx intensive, as we all know. In the middle, we have the site solutions, and those and antennas are part of that. High-performing antennas with high beam efficiency will improve uplink, as you're going to see in a second here. The next question becomes then is, how do we achieve that high-performance antenna? So it starts with a holistic, innovative, end-to-end development approach. So Ericsson leverages multiple tools to ensure that antennas are seen in the full context of the network and not as an isolated element of the network. And we have that know-how, and that's what we are leveraging. We are leveraging by using digital twins that can improve the prototyping accuracy and timing tremendously. We can simulate. We use the same network simulators that we use for massive MIMO radios, we use for antennas. So we understand how change in the design, change in the specs of the antenna will impact the whole network. And by doing that, we are seeing improved coverage, enhanced quality, and again, superior uplink capacity. All because the beam is more efficient, because the antenna has the right configuration, the right characteristics. So moving from R&D to, I would say, what is really hitting the street, so to speak. Ericsson has recently launched that Trio Net design antenna, which aims to boost performance, improve efficiency, and also with a lower TCO and carbon footprint. So if we start from the left here, you're going to see that there is innovative technology that improves the beam efficiency to 85. I mean, it's super important that you guide the beam to the place you want and minimize the losses. And 85% is a good number. In addition to that, all the chamber system, laser welding technology, etc., that has been developed for those antennas, they allow for, we are seeing 15% more uplink throughput. And you're going to see the benchmark shortly where that data has been empirically measured in multiple situations. Now, if you go to the mechanical side, the right side, well, sustainability is front and center. So we have developed that rundom that is made of 100% recyclable material and is also lighter. We also have those vortex generators that minimize the wind load by 20% at least. And that, as we know, put less stress on the antenna, less stress on the tower. And when you have that multiplying thousands of towers, I'm pretty sure you're going to save a couple $1 million in structural reinforcements. And then finally, those antennas are also lighter for the reasons I described, and they have smart brackets that makes the installation significantly easier and safer, right? We really want to make sure that when we're installing our 5G gear, safety is paramount, and a light antenna with this market bracket, we are seeing we did time and motion studies, and we are seeing that improvement. But it's not only about passive antennas, right? So if I go, so with all the new spectrum assets, with the fact that we are running out of space on towers, Ericsson has developed interleaved antennas, which combines low and mid-band, depending on the model, passive, with a transparent radiator that allows the massive MIMOs sitting behind and go through that antenna with minimal losses. And that's more complicated than you would think to make that happen in a proper manner. And obviously, the whole goal here is to have a simpler footprint, a smaller area in the tower. So not only makes feasible to add so many frequencies, but also the operator can optimize the site cost, the rental. So the question then, the final question that I think it's super important is how that innovative end-to-end holistic R&D approach, those innovative technologies, how does that translate into real life? So as you can see here, we have been doing multiple benchmarks across the globe. Some of those benchmarks, the results you're seeing here, were measured by our customer itself. So all of that is empirical data. It's not data that was simulated or is not theoretical. It's data that was measured live on the network. And more importantly, when we do those benchmarks and we replace whatever antenna there is with our next generation antenna, the Trio Net, we are only and solely changing the antenna. We are not changing the radio configuration. There is no further optimization. So it's really an apple-to-apple comparison. We also, we even see antennas connected to different RAN vendors, and there is absolutely no way to optimize that. If I can pinpoint a few examples, if you go to the left corner down, you can see that we have that operator in South America that compared our antenna in suburban and dense areas to whatever antennas they were using, and the results were incredible. And that is measured by the customer. You can see here the uplink going up tremendously. Similarly, if you go to the right in the center, 29% improvement on the uplink, up to 2 dB uplink improvement. That's what we have seen in Europe as well, because those antennas, given the technology and how they're built, they have less ping. They have a more stable ping. They have less interference. And together with the beam efficiency, that significantly improves the uplink. And then just like the last example here, because those antennas have better gains and less interference, the operator has the choice either of increasing the coverage using the same radio at the same power levels, or you can keep the coverage and lower the power consumption of the radio, because you can power down the radio a little bit. And you can see here in real case where we see up to 29% energy savings by having that approach. So thank you very much again, and back to you, Gabriel.
Hey, thanks, Rodrigo. So we're going to go to the Q&A now. Please, we've had a lot of questions in already. We're going to work through them where we can. What I'm going to do, though, before I go to that, Rodrigo, I'm just going to push you very quickly back to your last slide. So to get these are empirical data, right? And to do this, you just changed the antenna, is what you said, I think, if I understood that. So just to clarify, you didn't change the radios. You didn't even, this is the point I want to clarify, you didn't even change the cabling, to be clear on this, right? So this is performance versus a previous generation, but running the same cabling. So much problem with cabling operators often have. Is that the case here?
Yes, the only thing that was replaced was the antenna. So we didn't have further optimization or we didn't change the power levels of the radio. So it's a true apple-to-apple comparison.
Yeah, okay. I think that's quite an important point to make, because oftentimes you get like cable or radio upgrades at the same time, and at the end you never really know what you're talking about, as it were. So thanks for the clarification here. So we're going to go to some questions. We've had a good number in. Let me start with one that I think could work for both of you, okay? For you, Rodrigo, it's around the interleaved antenna slide that you had. But we have an operator, actually a European operator here. I'm going to go to you first, Ranjit, asking about how do you think about all the new bands that will be coming in future that you're going to add to a site? So just, obviously there's lots in that, but just talk a bit about how you think about that, Ranjit, and then Rodrigo can come in. I guess there's lots of new bands coming, particularly in North America, quite a diverse band plan, right?
Yes. No, I think it's a great question, and it is one of the topics that operators are always kind of working with because of the fact that number of bands are increasing, but at the same time, one has to also consider how you manage your OpEx, your site rentals, zoning, etc. And in order to address that, there is actually an interesting solution that we have in our Ericsson's portfolio, and we call this an interleaved antenna solution.
Yes.
Right. So, which basically what it does is that it is a combined passive antenna together with an active antenna. So it can beam through, so you can mount the active antenna component. Say, for example, you have a new band coming up, and which needs a massive MIMO radio. You have a passive antenna, which is an interleaved antenna, and then you mount the active antenna behind so that it can beam through your the interleaved antenna itself, so that from a site rental perspective, site acquisition perspective, it's same one antenna. It looks like a one antenna, but it's actually two antenna together. Anything else you want to add, Rodrigo?
No, I think you said it all. What I would say is that in order to keep up with the pace of new spectrum, we are also making sure that the bandwidth that those antennas support passive keeps in line with the assets that we're seeing being deployed on the low band, on the mid band. So it's important that that is up to in line with the spectrum evolution for the obvious reasons that Ranjit said here.
Yeah, okay. Another question for you then, Rodrigo.
Yes.
When we think about North America, the different operators there, two countries really, whether you want to include Mexico as well, I don't know, but there's a very diverse set of band allocations. You know, frequencies are allocated quite differently. Different operators have a different spectrum outlook, basically. If you compare it to, say, Europe, where it's relatively more homogeneous. Yes. So these operators are selecting an antenna. They go, I want to buy one from Ericsson or whoever. How do you kind of optimize your product? You know, things like your centering on different frequency bands, optimizing different combinations between these different operators.
Well, I think it starts with a customer-centric approach. What we do is we make sure that we are listening to the customer. We understand the customer strategy. We understand their roadmap. And then we can tailor the antenna to each of those use cases or those requirements in a way that you have a broad combination of 5, 6, 8-foot antennas. You have slim antennas. You have 8, 12 ports. Basically making sure that whatever you're putting there on antenna-wise is the most optimal configuration for the spectrum assets that you have or you will have in the near future, right? So the way we do that is really making sure that those requirements and that roadmap is embedded in the development and the roadmap of our products, making sure that we have the products that fully address our customer needs.
So you can kind of get some level of customization then in terms of, I'm centering around this set of frequencies, or I might have this frequency.
Yes. I mean,
we have seen different products for everybody, but can you you're getting something adapted for your plan, your band plan.
Yes, yes, because what we see is that different, even if you look into US, different operators have different requirements, different bands, different lease agreements with the towers, right? Different strategies as well. And that implies slightly different models. I mean, it's the same platform, so to speak, high technology, all that very cool technology that we went through, but then you have variances that meet those specific customer requirements.
Yeah, okay, good stuff. So another question I think is going to go to both of you. Maybe I will, let's start with you, Rodrigo, and then
Sure.
See how we go. So that example that we have of the sort of programmable network, the remote electronic tilt example that we talked about, that Ranjit introduced. Tell us a bit about, like, you know, is it something? And Ranjit, I'll have your thoughts on it as well in a moment, or you can go first if you like. The remote electronic tilt. You know, being triggered by an R app and all this kind of stuff according to time of day. I've been generally under the impression that RET is done on a more less granular time basis. So it might be a monthly or quarterly or even annual kind of adaptation. Is this idea that we can do RET on a daily, hourly, time of day, special event basis? Is that something that's active and common, or is that something you're projecting?
You want to go first?
Yeah, go. You start, and then I'll complement.
Yeah, no, it's a good question, Gabriel. This is something. I mean, yes, it has been the case. Like RET, normally you optimize the network and you leave it that way, and that's how this is how the static-based optimized network has been so far. What we are going forward to, we are not there yet, is the concept of when going to this autonomous network. As you know, we can do cell shaping over massive MIMO radios. That's already possible today, and we do not have to do any tilt or anything like that. Just the shaping the cell on the massive MIMO. So we are looking into how we can also do the same thing with RET from a passive antenna perspective as well, and because the FDD is such a critical band, especially for deep indoor communication, and then the users are moving around. It's not there. You're in the office. You're back home. So why have the antennas pointing in one way when there is actually nobody in the office? So yes, this is what we are going towards. It's not going to be as frequent as in seconds or milliseconds. It's going to be, hours. Like, okay, this is when it is, and during 9 to 5, and then later on it goes in the evening. We are not there yet, but this is where we are going in.
Yeah. Okay. Good stuff. We have quite a few questions. Maybe I'll start with Rodrigo, but then go to Ranjit. Quite a few questions. If I could sort of bundle some together on power consumption, and if I may change that to sort of power efficiency. A lot of people are asking about how you reduce that. Is that something, Rodrigo, that you really can, you in the antenna domain can have a big impact on, or is it not more in the radio and the PA efficiency and all those kinds of things? So tell us about on the antenna side to start with, how you can.
Well, it starts with an antenna that is highly efficient. When I say highly efficient, it's highly efficient from a beam perspective. It's highly efficient from a coverage perspective. And what those antennas, high-performance antennas, enables is that because they have better gains than the typical audio antenna, you can you have two choices, and that's what we have been talking to customers. Have two choices. One choice is increase the coverage area if you desire so, and then there is energy saving in the sense that you might have less need for densification, or you keep the coverage, but then you are able, because of the higher gains, you are able to reduce the power of the radio, and that's what we have seen in one of the benchmarks that I just described it. So yes, I think it's a combination of radio and antenna, but antenna is something that I think, I think it's more critical than, and is becoming more critical even yet than we have been thinking so far.
Yeah, because I guess it's if you can win performance there right at the first step, then obviously that's going to feed through the whole system. I mean, it's yeah. Explain one point, Rodrigo, on your chart. UE battery life extension. Can you explain the link to antenna performance and the UE battery life? Obviously, we all want that.
So a good antenna will enable better modulation, lower RSSI. There is a lot of parameters that are super nuanced and granular. And when you have an antenna that has high efficiency, has being super directional, well, then the device is going to spend less energy trying to capture and stay hooked to the network. And as such, because the device will have better signal more often, automatically the device consumes less energy. So that's the connection, Gabriel.
Yeah, okay, good stuff. Got a few more. Let's see, they're a little bit outside of our area now, but let's just see. So in a way, this is a bit of a gimme, but let me ask, Rodrigo, go to you first. It's not your product, but stand by. Are active antenna systems available or planned for low frequency bands, even if they're offered in a compact or reduced form factor? Now, obviously, that's not what you're selling, right? You're selling passive FDD systems. So the person here is asking about active, AAS systems for low band and FDD. How does that play in, I guess, the interleaved system that Ranjit was talking about earlier?
Yeah, so first and foremost, we sell passive and also interleaved, to your point, Gabriel. We sell both. But when it comes to FDD or TDD AAS, there are multiple different models of interleaved that we have been developing, again, in conjunction with our customers. And some of those configurations allow you to have a TDD massive radio on top, on the higher bracket, and then you can have an FDD AAS radio on the bottom bracket, right? Mm-hmm. So this is reality, and we expect that to start to be deployed very soon.
Maybe can I just complement what Gabriel just mentioned? So from an active antenna perspective, as Gabriel mentioned, we have our products on TDD side, which is TDDS. It's a sub-6 active antenna. We also have active antenna AS antennas for FDD as well, which is commercial as well, for band 25, band 66. We are also coming out with a tri-band antenna for FDD antenna, AS antenna for Latin America markets. What if the question was around sub 1 gigahertz, then sub 1, then like 600 or 700, 800 megahertz active antenna. This makes it, this is an area that we are looking into right now, but physics is physics. To build an antenna with such low frequencies for an active antenna is going to be a massive, very, very large antenna. So it's not a question of whether it's technically possible. Yes, it's technically possible. Whether it's deployable, what benefit we get is something that is being studied right now. So yeah, that's, if you're looking at below 1, then like 1 gigahertz, then that's where we are. Yeah.
Okay, you're worth a mention actually. On November 11th, we're hosting another webinar with some of your colleagues at Ericsson on active FDD antenna systems. They're going to have look that up because they've got two guest operators, one from Australia and one from North America, who are going to join them for that. As you say though, Rodrigo, you're always, pretty much always, maybe not in the long run, but for now you're going to have FDD passive in there as well for sure in the mix.
Yes.
Even if it's part of the sort of mechanical integration or so forth. Rodrigo, what is the, I think you mentioned, maybe this is for you or maybe it's for Ranjit, but it looks like for you guys from your chart there, you go from a 4T 8R system, seems to be your kind of sweet spot on passive. From there you jump to the active antenna system. Have I understood that correctly? I think maybe it's a radio question more for Ranjit, but have I understood that?
Yeah. I can start. Yes. So answer is yes. We have seen the operators go from started with, of course, 2T2R to went into 44R. Then now they're looking into 48R. And again, 8R primarily because uplink is always the king right now, and everybody is focused around the uplink. So yes, there is a lot of focus around how we can get more uplink into it, get more into indoor by having additional number of receive path. So 8RX is something that operators are looking at. And you said it very right, Gabriel. So yes, that's our sweet spot from an FDD perspective. And then next step would be for further efficiencies, it's the FDDAS where you can do beamforming as well.
Yeah. Okay, let's see what else we got here. There's quite a few of these, I think, are beyond my understanding to even ask them. So I'm going to have to get them taken out on the follow-up. I mean, I could try these. These might actually make more sense to you than me, Rodrigo. I mean, this is kind of maybe should be in your wheelhouse a bit, but please list the antenna parameters which contribute the most to high performance. I guess that's what you talked about in your whole session, really. But just recap the.
I think the one thing that comes to my mind in all conversations is pin stability. If you have a precisely engineered antenna with the right technology, you're going to have a pin that's below industry average, which is the case that in our case here. And I would say that if there is one, I mean, there are many more, but I mean, I think what I'm hearing more and more is that this is a super important topic. That's something that really degrades the performance of the network, and anything that can be done to improve that, I think is gonna, it's a significant gain.
So your PIM number essentially is one of the absolute key metrics that yes. You're looking at. Yeah. Yes. Okay. And talk if you would about the difference, or if it's the same thing between. You talked about a precisely engineered or designed antenna. What about the level of precision in the manufacturing and why that matters? Because obviously, it's one thing to have a design; it's another thing what comes off the what comes off the line, as it were, and how you know that you got a good one and in the before you ship it and things.
No, I mean, you're spot on. I mean, I would say that if I would have to summarize the challenge of developing a new product, and antenna is no different than that, one is the development of the product itself to make sure that specs are good, is serving customer needs. But also then the next question is, how do you scale that in a consistent manner with a low rate of failure and high quality? I mean, Ericsson has invested a lot in those manufacturing hubs. We have developed innovative technology that minimizes or increases, I would say, the precision. Like laser welding is something that it's super high end, and that allows for a much cleaner chamber system, so to speak, and also better pin, etc., and better consistent. Obviously, needs to. I mean. Everyone, I would say, would assume that, but I think quality control, it's super important. Every antenna that gets out of our production line is pin tested to ensure that it's meeting or exceeding the minimum threshold. And obviously, the goal is to minimize that number of antennas that are not meeting that. And I would say that, as anything, there is a ramp-up curve, but I think we're getting there pretty fast with the know-how that we have.
Yeah, I definitely think manufacturing's a little bit been under the radar, a little bit underappreciated over the years. I mean, just with on paper the designs match out, but the reality's not always the same now. I think that's quite a big shift you're seeing in industry in general. Is manufacturing's just becoming so. Even we talk about software all the time and so forth. But starting at the hardware and building the right product, you know.
Well, if I would add, it's not only about making sure that you have manufacturing with the highest possible capabilities and best quality, but also where those manufacturing facilities are located. We know that the geopolitical situation is quite fluid now, and being able to have a diverse supply chain, including manufacturing, that makes a huge difference in terms of de-risking the operation of all our customers.
Yeah. Okay. Another quick one. Well, it's as quick as we can here with this one. This is for an operator let's say, on the borders of Europe, between Europe and the Middle East, let's put it that way. Turkey. Low band 2T versus 4T antenna. Is it efficient to use a higher one, so 4T, even if the terminal side does not support it?
Oh, that's a pretty...
Not sure. Can you repeat the question one more time, Gabriel?
Is it? I think if I paraphrase it, is it worth having a 4T antenna, 4T/RX, even if your devices are only 2T capable?
Oh yeah, absolutely. So yeah, it really, it's a matter of 4T. It's all about getting the different transmit path, and that's how basically it doesn't matter if you have two T's on the UV side. 4T definitely provides the benefit of having the multiple reflections getting into for the 4 paths of the signal. So it definitely gives you much better downlink performance having a 4T transmit.
Sure. Okay. Good stuff. So a question to close us out. Then I'll go to you, Rodrigo. I talk about the differences between rural versus urban environment, and how does that change the antenna design and configuration? I mean, obviously urban is very dense and there's a lot of interference. Rural, you want coverage. What does that actually net out as in terms of a product that you deploy?
Yeah, so what we see is not only about the characteristics of antenna in terms of beam and pin, etc., but also size. As you get in denser areas, the limitations associated with the size of the antenna becomes more prevalent versus rural, where you have a little bit more freedom. So the challenge then is how to package that into a size that is in line with the customer requirements, with the code of each of the cities, at the same time making sure that the performance is not lost, right? And that's what we have been doing. And I think I said that before, but we have models on 5, 6, 8 foot, 8, 12 ports, etc., exactly to be able to address those different use cases, those different scenarios in the most optimal manner.
Yeah. Okay. One for you here, Ranjit, I think. It's not for you, Rodrigo, because it's an active antenna question, but a good question from a European operator here. Good evening from Switzerland. What would be the clear benefits you notice, if any, from moving from 32T, 32R to 64T, 64R, given the present day handset market? You able to handle that a little bit, Ranjit?
Yeah, so in the US, we have primarily got 64T, 64R. Of course, that is provides the best possible gains. If you have a much better elevation beam forming over vertical as well as the horizontal. So the flexibility of deploying a 64T compared to a 32T from the perspective of deployment is much bigger. For dense urban areas, 64T basically provides a much better efficiency compared to a 32T. 32T could be an option depending upon what the market is for, maybe where your traffic is not, if you don't have too many high-rise buildings, or where you do not need to beamforming on the vertical elevation. 32 plays as well. So it depends on the scenario where you're looking at, but 64T is extremely prevalent in the US, mainly to give the flexibility of future-proofness.
Yeah, yeah. Okay, good stuff. I think on that note, we've come to the top of the hour, so we're going to close down the webinar now. A bunch of questions we haven't got to. I'll ask the Ericsson team to have a look after and see if there's anything they want to follow up with. Obviously, if you're working for a competitor of theirs, they're probably not good news, just to understand that. But those from customers and prospects, I'm sure they'll be wanting to get back to you as well on that. So thanks to Ranjit and Rodrigo for being with us today. Thank you very much, gentlemen.
Thank you.
Thank you.
Thanks for the audience for listening to us. Thank you.
Yeah, really, really good to have you. And I'll just echo Rodrigo's sentiment here. Thank you very much for coming, and goodbye.
Likewise. Bye-bye. Ciao.